Today's lesson is on properties, and the Common Core standard is MA 622. Use numbers and their properties to compute flexibly and fluently and reasonably to estimate quantities. So this has a lot to do with rules that have to do with addition and multiplication in terms of patterns and different observations that we can have when we're focused on these two specific properties. So once again, make sure your title, your learning goal, your date are all set on your right-hand side of your page. But also make sure you've rewritten the title on the left-hand side, you've put the learning goal in your own words, and you've given me 1 to 2 sentences on what you already know about this topic. Please also view the right-hand side template to see that you've actually set up your notebook properly and you're ready to take your notes. As we work through each topic, what I will do is click and drag some paper template over that specific box to show you where we're going to take those notes. If you flip up the tab that I'm working on, you can write directly onto your notebook paper. Let's start with the associative property of multiplication. The associative property really is the order of the numbers. And so when you're talking about the order of the numbers, you can reorder any set of numbers in multiplication as much as you really need to. So associative property is really that the order of 2 or more factors can be rearranged. And I am going to be writing in colors that will help you to organize your notes a little bit today. So if you have your Sharpie pens, you may use them and follow along in terms of the color coding as well. So an example for the associative property for multiplication would be 3 times 4 times 7 equals 3 times 4 times 7. Now, you may be looking at this and thinking, what are those parentheses? What are they doing there? In math, especially when you move into algebra, parentheses are often used for multiplication. What they say, first of all, is that you have to do what's inside the parentheses first. Then you may multiply what is outside the parentheses. Because there is no particular operation that is notated between the 3 in the parentheses or between the 7 in the parentheses, you can assume it's multiplication. As you're solving the problem, the first side of the equation, 3 parentheses 4 times 7, first you do 4 times 7, which is 28, and multiplying that by 3 will give us 84 as our final answer. When I look at the right side of the equation, the first thing I do is multiply 3 times 4. That gives me 12. And then times 7, once again, gives me 84. So is this true? Absolutely. The associative property of multiplication tells me that I can reorder all sorts of equations when it only has to do with multiplication. So let's move on to the associative property of addition. Associative property, right? They have the same name. So what does that tell you? It tells you that the same rule applies for addition. The associative property for addition says when you have 3 or more numbers added together, the order doesn't matter. So again, similarly to multiplication, the order does not matter. And I'm sure some of you can figure this out just by looking at the problem and not even having to know that it's an actual rule. For example, 2 plus 3 plus 4 equals 3 plus 4 plus 2, right? 2 plus 3 is 5, plus 4 is 9, and on this side, 3 plus 4 is 7, plus 2 is also 9. So what it's telling me is that the order, once again, of these numbers does not matter. Let's move on to the identity property. And I'm going to switch to my orange pen. Whoops. The identity property of multiplication is interesting. It's an interesting idea because when you think about your identity, you think about what makes you you. So what is a number's identity, right? If I have the number 5, for example, what is its identity? Well, it's 5. It represents 5 things, 5 pieces, 5 digits. So the identity property is the property that tells you what you can do to a number in terms of multiplication that will keep its original identity. So the identity property for multiplication is when you multiply a number by 1. You maintain its identity. Or you keep its identity, right? And some examples of this are 2 times 1 is still 2. 7 times 1 is 7, right? 33 times 1 is still 33. So that's what they mean when they're talking about identity. They want to keep the number what it is, but they want to be able to do so in terms of multiplying. So if you think about the identity property of multiplication, the identity property of addition is very similar because of the fact that you want to keep that addition problem or that number the same. So think about what number could you add to any other number and keep it the same. You may have already thought 0. So when you add a number to 0, you maintain its identity. Right? And that makes perfect sense because if you have 5 and you add 0, you still have 5. If you have 17 and you add 0, you still have 17. And that will be the case for every single number in the world. We're going to talk about the commutative property. And the commutative property of multiplication has to do with order for only 2 digits. Commutative property says again, the order of, and we're talking specifically about 2 numbers. In multiplication, does not matter. And an example of that could be 2 times 5 equals 10, but 5 times 2 also equals 10, right? So the order of that problem does not affect its solution. So the commutative property of addition, you should already be thinking, the order of 2 numbers in addition does not matter, right? So I'm just going to write an example here. 3 plus 7 equals 10. 7 plus 3 also equals 10, right? It's very similar to the commutative property of multiplication. The order does not matter. We're going to skip distributive property of multiplication and distributive property of addition for now. We'll talk about these in class, so you may not want to scratch them out completely, but I will just for our note-taking sake. I do want to mention the zero property of multiplication. That zero property tells us something you may already know. Any number multiplied by 0 will equal 0, right? If you have 0 times a number, you will have nothing. You will have 0. So your example here could be something along the lines of 7 times 0 equals 0. You could also think of something very, very large, like 2,791 times 0 is still going to equal 0. This is what your completed template should look like on your right-hand side of your notebook. You should have all the notes in the proper boxes so that when you open up your flaps, you'll be able to see the description of each particular property. What you are required to do before you finish your notes is to fill in the what I learned portion of your notebook. Also, the proof. The proof problem says which property is identified by the equations explain. So here's one equation. And here's the second, and here's the third. Now that I look at it, this first one has to do with distributive, so go ahead and skip that. Also, to do your reflection, use any of the reflection ideas listed in your journal. This should be a completed journal entry prior to next class.